Dr. T.V. Geeta, Professor, Department of Computer Science, College of Engineering, Guindy, Anna University. Her special interest, Artificial Intelligence and Natural Language. She has published more than 143 articles in national and international journals. She has guided around 7 PhD students. She has got Young Scientist Award from Government of Tamil Nadu in the year 2000, Chief Minister's Special Mention Award in the year 2002 and Woman of Excellence by Rotary Club in the year 2003.
Welcome to the UGC lecture series. In this lecture, we are going to talk about what are called as transactions of databases. In transactions, we are going to look at it, what are transactions from different viewpoints. Then we are going to understand the need for recovery, and then we are going to explain the operation and states of a transaction, and then we are going to have a look at what is meant by system log. First of all, before we start off, we must know what is a transaction. So, transactions can be looked at from different viewpoints, whether it is an application viewpoint or the database designer viewpoint or the database administrator viewpoint. So, accordingly there are a lot of definitions of transactions. So, first let us look at what is a transaction. So, when an event in a real world occurs, what happens? There is a change of state in the enterprise itself. I am taking a loan. That time the bank enterprise itself changes. Now, a transaction has to be executed such that this change results in a corresponding change in the database, because then only there will be consistency. The database is now acting as a reflection of the enterprise. If it is an online database, then this event which caused a change in the enterprise has to be carried out in the database in real time. What is a transaction? It is an application program with special properties, and what is its special property? It has to guarantee that it maintains the correctness of the database at all times. When we go to transaction, we have to talk about read and write operations. First, a transaction. Now, we have looked at transaction from an enterprise viewpoint. Now, from a database viewpoint, transaction is an executing program that forms a logical unit of database processing. That is another definition of transaction. And normally, a transaction can include one or more database operations, access operations. So, a set of operations together forms a transaction, and it has to be a logical unit of the database processing. The database operations can be embedded within an application, or you can specify using a high level query language. Now, there is a specified boundary which is given by the begin and end. So, a transaction will involve a begin and an end. So, when you begin a transaction and you end a transaction. If the database operations in a transaction do not update the database, then it is called only a read only transaction. That is, you are just accessing data, you are not causing any changes in the database, no values are changed. Then if only those operations form part of the transaction, then it is called a read only transaction. As I already explained, transaction is a basic logical unit of execution in an information system, and it is a sequence of operations. Now, what is important is the whole sequence has to be executed as a whole, and it has to take the database from a consistent state into another consistent state, consistent and correct state to another consistent and correct state. There is no question of that you can do part of a transaction. A transaction has to be done as a whole, and that is one property we have additionally added. So, first, a transaction is a sequence of operations. 2, it has to be the complete sequence has to be executed as a whole, and when you execute a transaction, it has to take the database from one consistent and correct state to another consistent and correct state. A collection of actions that make consistent transformation of system states while preserving the system consistency. So, this is the definition taking off from the previous, and it is an indivisible unit of processing. The meaning of that is you either you execute the transaction as a whole or not at all. There is no question of partly executing a transaction. So, it is called an indivisible unit or an atomic unit of processing. Let us look at this again with an example. So, you have a database in a consistent state where you have account A belonging to Ram has rupees 1000 and account B belonging to Krishna has rupees 0. Now, this is the state of the database before the transaction began. Now, you must do the execution of the transaction, which is transferring of rupees 500. This requires a lot of database operations. We are only talking about the transaction as a whole. So, you have to transfer rupees 500. When you do the transformation, at the end of the transaction, the database must again be in a consistent state. That is, account A of Ram should have 500 and account B of Krishna should have 500. So, the database may be temporarily in an inconsistent state during the execution. I will tell you what happens. You are transferring, the one operation is you are reducing the amount available with RAM from 1000 to 500, but you have not executed this, that is you have not changed Krishna's account B from 0 to 500. Then at that point, before you do the changing of Krishna's account, it is in an inconsistent state, because the bank the database would have actually lost 500 rupees because of the fact that the transaction has not completed. So, you can, that is what is called an inconsistent state. But when you do a transaction, either you begin the transaction, end the transaction, it should be in a consistent state or consistent state. Due to some problem you are not able to complete the transaction, then you go back to the original state. Always a transaction takes a database from one consistent state to another consistent state. Now, that is a transaction. Now, let us look at what is a transaction processing system. Now, a transaction execution is controlled by what is called a transaction processing monitor. This creates the abstraction of a transaction, which is analogous to the way an operating system creates abstraction of a process. So, this creates an abstraction of a transaction. The transaction process monitor and the database management system together guarantee the special properties of transaction. So, along with the transaction processing monitor and the database properties, it will guarantee that the special properties of transaction are maintained. Now, let us just revise on what are the special transaction. Transaction is a sequence of operations. It is to be executed as a whole, that is, it has to take the database from one consistent state to another, and it is an atomic unit of operation. A transaction processing system consists of three things: the transaction processing monitor, the databases and the transactions. Now, these are the transactions, and this is the transaction processing monitor, and these are the databases, database management system, and this is the database. So, these three things together is a transaction processing system. Now, let us look at what is the meaning of transaction processing. We just looked at what is the meaning of transaction, what are the special properties of transaction. Now, we are going to look at what is the meaning of transaction processing. Now, one criteria to classify database is according to the number of users that concurrently connect to the system. This is before we go into transaction processing. So, you have a single user system, that means at a time only one user can access the system or use the system. Multi-user system, most database management systems are multi-user systems today. So, many users can access the system concurrently. Now, what is the meaning of concurrency? Now, that is the next question. You have interleaved processing and parallel processing. Interleaved processing means concurrent execution of processes is interleaved, but you have only a single CPU, or you have concurrently it is executed using multiple CPUs. So, let us look at what is the meaning of interleaved processing and parallel processing. So, here you have only one CPU. What you do at time t1, time t2, this is A and B. So, this is A, this is B. So, first you will do A's for some time, then do B's, then do A's again, then go back to B, but you are using a single CPU. So, this is called interleaved processing. It is a concurrent transaction, and then you have parallel processing where you start at T1, T2, you have two CPUs, one CPU taking care of A and one CPU taking care of B. So, this is parallel processing. Now, single user versus multi-user, one criteria to classify which we already saw is the number of users, and at the same time they will be using the system. Now, why do we need transactions? It is all about fast query response time and correctness. We are very bothered about the consistency of the database, otherwise no one will land up using the database. At the same time, if you want a user to use a database, you have to respond to his queries in a efficient and fast way. So, most database management system of today are multi-user systems. You have many different requests coming at the same time, and sometimes the request may be against the same data items. What I mean by this is, one person, for example, I have a family which or I have a company which has 5 people have access to the same account, account number. 5 people will be doing different transactions on the same data account of that person. One person will be depositing, one person will be removing or depositing, or he may be withdrawing and so on. So, if you happen, that means the same data item will be accessed by multiple users. How to interleave requests to shorten response time while guaranteeing correct result is one of the major issues that you talk about in transaction processing. And the database management system at the same time should know what are the actions that belong together. So, the solution is to group database operations that must be performed together into transactions. So, a transaction is a logical unit of this, we have already seen data processing. What are the operations that sequence of operation that make up a transaction? Retrieval, which is read, write, insert, update and delete. So, you can have insert, update, delete or retrieval. And as I already told you, a transaction is a set of operation. It can be written in SQL or maybe embedded in a program. And the transaction boundaries, a transaction starts with a begin statement and ends with an end statement. An application program may contain several transactions which are separated by begin and end. Now, what we have? We have program which has several transactions. Each transaction has a sequence of operations. These operations can be read operation, write operation or delete operation. So, again a transaction is a logical unit of databases that include one or two database access operations, and we have read versus write transaction. Read transactions means only read operations, no insert, no update, no deletion. The operations of a transaction is an action on a database data item, and transaction is a set of such operations, and now remember it has to be done in a particular order. So, a transaction makes a set of operation appear as one logical operations. Now, each transaction will do something in the database, no part of it alone achieves anything of use, and transactions are also fundamental unit of recovery, consistency and integrity. So, we do not talk in terms of database operation, we talk in terms of database transactions. So, what is a transaction? Just to wind up, it is a logical unit of work, it is a unit of work with respect to. So, when we talk about concurrency and recovery, we are not talking about operations like read or write, we are talking about a set of operations which forms a transactions. A sequence of operations including database operations that is atomic with respect to concurrency and recovery. What we are trying to say is a transaction will be executed. If it is executed, it will be executed as a whole, that sequence of operations completely will be executed, otherwise it will roll back. I will not use that term now, but it will go back to its original consistent state. So, when we talk about concurrency, that is two users using, or when we talk about recovery, getting back the original consistent state, we are always talking in terms of transactions, we are not talking in terms of operations, database operations. So, again a transaction is an atomic execution unit that when applied to a consistent database generates a consistent but possibly different database. So, a transaction acts in such a way that it converts a database in a consistent state into another consistent state, which may be the same if it is only a read transaction, or maybe a different database or changed database if it is a insert, update or delete operation. It is a short sequence of operations with the database which represents one meaningful activity in the user's environment. This is another way of looking at transaction. It actually means one meaningful unit, like for example transfer rupees 500 that is a transaction, but that requires reading A's, deleting amount from A and then putting it into B, all that together forms a transaction. So, a simple model of a database from a transaction perspective. A database is a collection of named data items, and the granularity of data can be a field, it can be a record or it can be a whole disk block. So, the concept that we are talking about are independent of what we are operating in the granularity. So, let us look at some operations. We have read and write operations, these are basic operations. So, read item X reads a database item named X into a program variable. To simplify our notation, we assume that the program variable is also named X. So, just read a item, and then write item writes the value of the program variable into a database item named X. So, basic unit of data transfer from disk to the computer main memory is one block. In general, a data item which is read or written will be a field of some record in the database, although it may be larger units such as a record or even a whole block. Up to now, we have looked at the basic things associated with the transaction. What is a transaction from the user viewpoint and also from the database viewpoint, where database viewpoint looks at this transaction as a whole, as an atomic unit, and is all concurrency, your interleaving and your recovery, everything is based on this transaction. So, now let us take a small break. Welcome back after the break. Before the break, we were describing what is a transaction, and we are going to look at each and every operation associated with the transaction now. So, now let us go into detail about what is the meaning of read item X command, which is used in the transaction. So, you remember transaction consists of a sequence of operations. What is the meaning of this? You have to find the address of the disk block that contains item X. You have to copy that disk block into a buffer in the main memory if the disk block is already not in the main memory, and then you have to copy item X from the buffer to the program variable named X. This is the meaning of read item X. So, you have to go to find the address of the disk block, then you have to copy it into the buffer, and from the buffer you have to copy the item into the program variable. Similarly, what is the meaning of write item X? You have to find the address of the disk block that contains item X, and then you have to copy the disk block into buffer, and then copy this item X from the program variable into the correct location in the buffer. Store the updated block from the buffer back to the disk, either immediately or sometimes later also. So, this is write item X. So, let us look at two sample transactions, transaction T1 and transaction T2. Now, transaction T1 you will read the item X, then do some operation X equal to X minus N, then write the item X, read item Y, write make Y, change the value of Y is equal to Y plus N, and write item Y. Or you can read item X and X equal to X plus M and then write the item X. So, these are two simple transactions. So, now let us look at the role of transaction and transactional recovery. Before we go into that, let us look at, remember, let us look at what is recovery or why recovery is needed. Before we go into that, remember I said that when a transaction is done, it has to be done as a whole. Okay, you can, I mean as an atomic unit, you cannot do some operations on the database with sequence of operation and not do. So, if you begin at the beginning of a transaction, it has to end at the end statement of a transaction. So, again taking that example of transfer of rupees 500 from Ram's account to Krishna's account, if you just remove 500 from Ram's account and then for some reason it fails, then the transaction has failed, and so because the transaction has failed, the database is in an inconsistent state, so you have to recover. So, now let us look at what are the types of why recovery is needed, what are the types of failures. One, you have system failures, this occurs several times a week and recovery required in a few minutes. So, a computer failure is a system crash, a hardware or software occurs in the error occurs in the computer system during the transaction execution. So, during the execution of a transaction, if an error occurs where the hardware crashes or the software stops working, the contents of the computer's internal memory may be lost. So, the whatever transaction you have done, the small operations whatever operations you have done and the change in the database may be lost. The other type of failure is communication failures. This occurs very intermittently and the recovery time depends on the nature of the failure. So, the recovery time is also sometimes a problem because of some network problem. Then transaction failures, this occurs several times a week and recovery requires a few minutes. What is the meaning of a transaction or system error? Some operation in the transaction may cause it to fail, such as integer overflow or division by 0, because when you are doing those operations it may happen. Transaction failure may also occur because of erroneous parameter values or because of a logical programming error. In addition, the user may interrupt the transaction during its execution. So, all these are called as transaction failures. Local errors or exception conditions can be detected by the transaction. Certain conditions necessitate cancellation of the transaction. For example, date of a transaction may not be found at all. A condition such as insufficient account balance in a banking database may cause a transaction such as a fund withdrawal from that account to be cancelled. A programmed abort in the transaction also can cause it to fail. This is a typical example of why a transaction you want to exception conditions or local errors may cause a transaction to fail. For example, in a bank withdrawal is come as a transaction. So, you know the set of operations you have to do for the transaction of withdrawal of money, but sometimes when the withdrawal does not, I mean the account does not have money, you can't withdraw. So, that time the transaction may fail and you have to go back to the original state. And then concurrency control enforcement. The concurrency control method may decide to abort the transaction to be restarted later because it violates seriability or because several transactions are in a state of deadlock, which we will see later. Next type of failure is media failure. This occurs once or twice a year. Recovery requires a few hours. For example, the disk may fail and so on. So, some disk blocks may lose their data because of the read or write malfunction or because of the head crash. This may happen during a read or write operation, which means that the transaction cannot carry on. Then sometimes you will have physical problems and catastrophes, that is, this refers to the endless list of programs that includes power failure, air condition failure, fire, theft, sabotage, overwriting disk or tapes by mistake, or mounting of wrong tape by operator. These are typical physical problems. With that, so now what did we see? We saw what was a transaction, then we saw what are the components of a transaction processing system, then we saw two typical operations of transaction that comes in the transaction, read operation, write operation, and we also saw what are the type, where we will need recovery. There are lot of places. What we meant by recovery is there are lot of places where crash can occur or failure can occur, which may cause the transaction to be stopped in the middle, in which case recovery is needed. Now, before we go to further, let us look at transaction states and additional operations. For recovery purpose, the system needs to keep track of when the transaction starts, when it terminates, and when it commits or aborts. So, what information, this is the information that the recovery manager has to keep track of. So, the recovery manager keeps track of the following operation: begin transaction, this marks the beginning of a transaction. These specify read or write operations on the database system that are executed as part of the transaction. And then you have end transaction, this specifies that read and write transaction operations have ended and marks the end limit of the transaction execution. At this point, it may be necessary to check whether the changes introduced by the transaction can be permanently applied to the database, or whether the transaction has to be aborted because it violates concurrency control. So, at this point of time, after the transaction is over, before we, what is the meaning of, before we save it onto the disk, either it has to commit, which means it will be saved, or it has to abort. So, these two operations are. So, commit transaction means this signals a successful end of a transaction, so that any changes or updates executed by the transaction can be safely committed to the database and will not be undone. That means, okay, this is over, this can be committed. Signals that the transaction has ended unsuccessfully, so that any changes or effects that were done as part of the transaction has to be undone. Transaction is an atomic unit, again to remind you. So, either it has to be completed in its entirety or not at all. So, for recovery purposes, we have to keep track of when the transaction starts, when it terminates, and whether it commits or aborts, as I already told you. For that reason, we have certain states associated with the transaction. The first state is the active state, another is the partially committed state, then you have the committed state, then you have the failed state, and then you have the terminated state. Again, we will come back to these states again, but recovery techniques use the following operators. So, when you want to recover, undo similar to rollback, except that it applies to a single operation rather than the whole transaction. So, you can undo one operation. Redo, this specifies that certain transaction operation must be redone to ensure that all the operations of the committed transaction have been applied successfully to the database. So, now look at this. This is the begin transaction. At that point of time, the transaction is active, and then when then you have all the sequence of operations, which is typically read write. You do that. So, that remains in the active state. After you finish the transaction, it is in the end transaction. So, when you come across an end transaction, it becomes partially committed. In the middle of this transaction, some operation, it may be aborted, in which case the transaction has failed. Now, from this part, now suppose you have successfully completed a transaction, it goes to the partially committed state. From partially committed state, you have two options. One is commit and abort. Commit means whatever changes you have done will be permanently stored onto the disk, so it becomes committed. If not, you will abort it for whatever reason, you may abort it, then it becomes fail. Whether it is committed or failed, finally it will go to the terminated state. So, when it comes to the terminated state, the transaction has been completed and committed, or has not been completed and failed, or partially completed but not committed. So, aborted, then also it comes to terminated state. So, again active is the initial state, the transaction stays in this state while it is executing. Partially committed, after the final statement has been executed, it goes to partially committed state. After the discovery that normal execution can no more proceed, it goes to the failed state. Terminated, after the transaction has been rolled back and the database restored to its state prior to the start of the transaction. Two options: restart the transaction or kill the transaction. And committed after successful completion. If a system failure occurs, searching the log and roll back the transaction that have. So, here again we have the same thing, you have the begin transaction, read write, then you have the end transaction which becomes partially committed. Then instead of writing abort, you have written roll back. Okay. This rollback means a transaction reaches its commit point when all the operations accessing the database are completed and the result has been recorded in the log. It then writes commit transaction ID. This rollback, if a system failure occurs, searching the log, so the log has noted and roll back the transaction that have been written to the log as start transaction, transaction ID, write item, transaction ID X, old value, new value, but have not recorded into the log. So, what happens if it fails and it has not been committed, then you have to roll back. Now, here we have talked about something called system log. So, what is the system log? The system log is nothing but the system maintains the log by keeping track of all transactions that affect the database. Log is kept on the disk and it is only affected if the disk fails or the catastrophic fails. So, it keeps a log of records. So, this log keeps track of the start of the transaction and the completion of the transaction and information needed to recover from the transaction failures. It is normally kept on disk and it is periodically backed on to an archival storage also, and this T is a unique transaction ID that is generated by the system automatically in order to identify each transaction. So, the types of log record you have are start transaction T records that the transaction T has started execution, write item T X old value new value records that the transaction T has changed the value of the database item X from old value to new value. Read item T X records that the transaction T has read the value of the database item X. Commit T records that the transaction T has completed successfully and its effects has been committed in the database, recorded permanently. Abort T records that the transaction T has been aborted. So, this is for the transaction T with the ID. So, let us look at, for every transaction a unique transaction ID is generated by the system. So, start transaction, transaction ID. So, that is first recorded, then so that is what, and then read transaction, the transaction identified by the transaction ID reads the value of the database item T, optional in some protocols, they do not want this. Write, this is the update protocol, the transaction identified by transaction ID changes the value of database item X from old value to new value. Commit, the transaction identified by the transaction ID has completed all access and it has been recorded permanently. This is where you have the failure. So, now let us talk a little bit about the commit point of a transaction. It is when all operations that access the database have been executed successfully and the effect of all the transaction operations of the database have been recorded in the log. So, the log also has to be recorded. So, beyond the commit point the transaction is said to be committed and it will be permanently recorded, and then the transaction writes an entry commit comma T into the log. The failure occurs, search in the log looking for all transaction T that have write start transaction T and roll back. So, this is needed for transactions that have a start transaction entry in the log, but no commit has occurred. So, if there is an entry commit T, transactions that have written the commit entry in the log recorded all the write operations, otherwise they would not have committed. So, their effect on the database can be redone from the log entries. Log file must be kept on disk so that it is not. Sometimes before transaction reaches its commit point, any portion of the log that has not been written to the disk yet needs to be now written. This process is called as force writing, forced to write it. So, what have we looked here? We have looked at what are transactions from different viewpoint. We have discussed threadbare all the properties of the transactions, and we have discussed some reasons why transaction can fail, and we have also looked at transaction operations and states, and we have looked at what are the entries that are possible in a system log which is needed for rollback. Here I have given you some theory questions. You have to define what is a transaction, you have to define what happens during the read and write operations, and you have to talk about what are the various causes of failure and explain in detail the state diagram of a transaction with how it goes from one state to another, and what are the entries in the system log and what is the commit point of a transaction. Thank you.